What's up everyone? Today we're going to go over Leetcode 112, valid path sum. First we'll look at the input and the output, then we'll look at the diagrams, and finally we're going to look at the code and complexity. The input is going to be a binary tree and an integer called sum, and the output needs to be Boolean true or false if we can go from the root all the way down to a leaf node such that the numbers in that path add up to this sum. So for 22, we have 5 plus 4, 9, 9 plus 11, 20, and 20 plus 2, 22, so we return true. Any path from the root to leaf is valid if we can have a valid sum, so only one is required for the output to be true. Here are the diagrams. What we're going to do is take our sum and pass it in to our children. So the parent is going to pass its child a parameter sum, and it's going to say, okay, every time I pass from myself to my child, I'm going to subtract my value. When this parameter and the recursive stack gets down to a leaf node, the leaf node is going to check, okay, we've subtracted every single ancestor or parent from the original sum. By the time it gets down to me, the value should be equal to the value of the leaf node. If it is, then we found a valid path sum. So, top-down void versus bottom-up Boolean. What's the difference? Here, the return type is going to be void, whereas here, the return type is going to be Boolean. Here, we're going to pass the original sum down, so 22 is going to be given to 5, and 5 is going to subtract itself from 22 to its children. So 5 is going to give its left and right child 17, 4 is going to give its left child 13, 8 is going to give its left and right child 9, so on and so forth. And anytime we get to a leaf node, what's valid, so the valid is where the value that's given in, 2 is equal to itself, 2, we have a global variable that's going to be a Boolean true or false. And if we get 1, that's sufficient, and we know we can return true. Here, what we have to actually do is give this sum to our children, and it's going to do the same thing, subtract the value. And if something is true, it's going to actually return up. So this one is true, so it's going to return true. Green is true, whereas orange is false. So all they're going to do is bubble up with the or, so false or true, 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 and this is false, so they're both going to return false. Ultimately, we return true. Let's compare the two versions of the code. Here's the top-down void, and here's the bottom-up Boolean. For this version, we're going to have a global variable called res, and we're going to use it to see if any of the leaf nodes that we visit satisfies our condition. If it is, we simply return res. So here's the recursive function. If the root is null, we return. Otherwise, if we're visiting a leaf node, we're going to see if the number that was passed in through the sum parameter is equal to the value of the node we're visiting. If it is, then yes, we found a valid path sum. So we just set the global flag to be true, and that's pretty much all we have to do. Otherwise, we simply recurse left and right and subtract the root's value from the sum parameter that was passed in. For the bottom-up Boolean, we have to actually wait for the leaves to return their answers. So here, we're just going to call it, and we have a return type of Boolean. Keep in mind, this return type Boolean is different than this void type Boolean. If we have a null root, we return false. Otherwise, once again, we check if we've seen a leaf node. If so, we compare the sum that was passed in to the value of the root, and if it is equal, we return true. Otherwise, we're going to return false. Otherwise, what we're going to do is just recursively call left and right, and we do an OR on both the branches. This is because we only need one branch to be a valid path sum. So if any of the truths from the left or right bubble up, then that's fine to get all the way to the top. Time complexity is going to be O of n because we have to visit every single node. And the space complexity is going to be O of 1 because we're not using any additional data structures to store state or anything like that. Of course, if you consider the recursive stack to be space, then the answer is going to be different, but I'm going to take it as constant. So that's how you solve Leetcode 112. If you like the video, please thumbs up, and if you want to see more, don't forget to subscribe.